as well as static electricity, which is just the transfer of electrons from the surface of one object to another. We also have what is called current electricity. See, current electricity is the continuous flow of electrons through a material, and it derives its name from the same idea as the current of a river or water. It is just the continuous flow of water, just as current electricity is the continuous flow of electrons. Current electricity is way more useful in our everyday life than static electricity, and that's because that continuous flow of electrons provides us with continuous nonstop energy. Just as the continuous flow of water in a river can be harnessed to actually do something like drive a windmill, we can use the continuous flow of electrons to drive the work that we need to have done. The only thing about current electricity is it has to have a few things in order to work. Number one, you have to have current electricity working in what is called a circuit. A circuit is basically when you have a complete connection from start to finish of whatever you have your electricity flowing through. I always think of a circuit much like the circuit in Mario Kart. Now, we've all played Mario Kart. We all pick Toad because he's the fastest one. And as we are winning the 50cc race with Toad, we know that we always start and finish at the same point on the track. The start line and the finish line are literally the same point because you drive on a circuit. For electrons, it's no different. They have to drive through a circuit where they actually start at the same point, go around, and come back to that original point. That is one of the requirements when we have current electricity. The other thing you need is some kind of power source. You need something that is actually able to drive those electrons and give them the energy and the push that they need. Just like in Mario Kart, if you don't hit the A button, they're not going anywhere, right? You have to actually have some force pushing forward. And the same goes when we have some kind of circuit set up. In order to have the electrons actually flow, you have to connect it to a source of power. These sources come in two different kinds. The two different kinds of current that we can produce are what is called alternating current, usually referred to as AC electricity. It allows electrons to actually flow in both directions around a circuit. You can kind of think about all the electrons being connected because electrons are in every single atom of that circuit. Having an alternating power source basically causes them to kind of shake back and forth. As they do that, they're able to power whatever is actually inside of that circuit. It may seem like it isn't that efficient because you think of electrons and Mario Kart flowing in one way, but for electrons, it's just as good. They can just vibrate back and forth, able to power different things. Because you're not really moving the electrons very far, you can really transmit AC electricity a long, long ways. And this is what we actually use to power most of our homes is we transmit AC electricity from power plants due to its relative ease in transmission. The other type of electricity is called direct current. Direct current is when electrons flow in one direction, and we would call this DC electricity. Direct current is often made by batteries, things that we would normally call an electrochemical cell, and it is also created by solar panels. They actually only drive electrons in one direction. We need DC electricity to actually run most modern electronics. A lot of the circuitry in our computers and phones requires electrons to flow in a single direction. If they don't, they actually can't physically go back. And so this is a really important thing. So even though we get AC electricity from the power plant, our homes and our equipment actually usually have something that converts it back into DC so that it can work in our modern electronics. The other thing we need in all circuits is we need what is called a load. We need something that actually is going to convert electrical energy into some kind of useful energy. You may not think of electricity in this way, but Electricity is kind of useless just on its own. Just like the river flowing on its own, yeah, you can go play, you can go have some fun. With current electricity, the continuous flow of electrons, if you just had that, then really it's not going to help you much. You can maybe shock people, keep your cows in a pasture, but what we really need to do is be able to use that energy for something else. We want to convert electrical energy into a different type of energy. And typically we would convert it into one of four different kinds of energy: heat, light, sound, or motion. By doing that, we can actually use the electricity to help us with things that we need. The things that do that are what we would call a load. As I mentioned, we can basically take a load, something that is able to convert electrical energy into some kind of useful energy, and those useful energies that we can create are light, heat, motion, and sound. Essentially, you can use something like a light or a lamp to convert electrical energy into light. Resistors convert electrical energy into heat. Motors convert electrical energy into motion, whereas speakers convert electrical energy into sound. Without a load, you create what's called a short circuit. Basically, a spot where electricity will just continuously flow, creating the actual wires to heat up and eventually possibly burn out or cause other issues. Without a load, it actually is very dangerous to have that circuit set up. The other thing that we end up needing to have inside of all of our circuits is also the path. You see, the path is just whatever is actually carrying that electricity. And in this path, it is very important to include a switch. Without a switch, you can actually never turn off your circuit. And so it's really important to set up all circuits so that they can eventually be turned off at some point, stopping that flow of electrical energy. You see, as soon as you disconnect that circuit and have the flow of electrons stop, all electrons in that circuit actually stop moving. Now, this is just a quick introduction into what current electricity is, but as we move on, we're going to take a look at how we actually use it and why it actually works the way that it does. So thanks for watching, and I'll see you next time.